the Data Services Office Hour. I am Michelle DiPalma, your host, and I'm here with Daniel Parks. Daniel, nice to see
Hi,
you.
hello.
Hi.
Nice to meet you.
Talk to me. You're regular on the show, but talk to me about what we're going to go through today.
Yeah, so the idea today is cover a little bit or speak about a little bit about multi-cloud gateway. That is always a topic that we like covering. And in this case, we wanted to give an example or a use case with a demo of how multi-cloud gateway can help you, like increasing your data resiliency when using object storage, you could say, with going hybrid. No? So we're going to have an application on premises, but we're going to be replicating also to the cloud. So we can have a use case and an example of how multi-cloud gateway can help you with this kind of a scenario.
Awesome. Okay, so can you give us a refresher for those who are not so familiar with the multi-cloud gateway about, like, are we going to be namespace buckets, replicated buckets? Like, do you have an overview? Okay.
Yeah, that's a good point. Let me share my screen, and even if we don't like to go or spend too much time with the slides, let's just cover 3 or 4 slides to give an introduction.
I guess we are a little anti-slide here. Okay.
Let me share my screen. And tell me if it...
Okay.
That's okay. You can see it fine. No? So just very briefly, again, just the introduction of MCG, of the Multi-Cloud Object Gateway, is part of ODF, of OpenShift Data Foundation. When you deploy ODF, it gets installed with ODF. And I would also bring up the thing that if you have a use case where you have an OpenShift cluster and you're working on a cloud provider and you only have a use case for object storage, you can deploy MCG in a standalone mode. So you can also save some resources by avoiding the deployment of the full Ceph deployment and all of the CSI drivers that really they provide you access to block and to shared file systems, so read write once and read write many. If you don't need those kind of storage accesses and you only need object, you could also deploy MCG standalone. That's actually something that you can do now with ODF 4.10.
4.10. Okay, I was going to say that wasn't true before, but now in 4.10 it is. Awesome. Yeah. Okay.
Cool. So that's a good point, just to save some resources. And then going into MCG, really, what's MCG? So MCG is like an S3 compatible endpoint that offers like a consistent experience to the developer, to the application. I mean by this that you're always going to have your S3 endpoint, you're going to have your bucket with your access key and your secret key, and everything is going to work normally. You can leverage your object storage, you can do puts, gets, and everything is quite simple and consistent from the application or the developer side. But then on the back end, behind the curtains, we have like a really flexible deployment with MCG, with many features. We support a really big array of backend stores. We support from on-premises, where you can have Rails Gateway, or you could have even persistent volumes that you could use as the backend store from OCP, or going into the cloud and the cloud providers, where we also support Azure, IBM, object storage.
I think you and we actually showed using a persistent volume as a backing store in a previous show. The one where we did MCG standalone on the edge. So look for that. Just telling you.
Yeah, that's a very good point. Yeah. So
okay.
So as we mentioned, you have like a huge array of backend stores, but also you have data policies by which you can configure and you can play with those backend stores, and you can configure packet replication, mirroring, different spreading between the buckets. So you can also do local caching. There are many things that the storage administrator can do in the backend, and in the front end, the developer wouldn't even notice. It's completely transparent for him. So this is really nice what Multi-Cloud Gateway provides. And going a little bit into how an application or how a developer interacts with the multi-cloud gateway, it's a little bit, it works the same as it would be with persistent volumes and persistent volume claims. For people that have already worked with stateful applications in Kubernetes or OpenShift. With multi-cloud object gateway, we have what we call object bucket claims. That is more or less the same philosophy that you will have with PVs and PVCs, in the sense that when you are deploying your application, if you need object storage, you can also create an OBC object, an object bucket claim, and that is going to in turn in Nuba, that is the upstream name for the project that we have for MCG, just in case you hear Nuba or you see some posts that are called Nuba, that's the upstream name for the project. We are normally going to call it MCG. So MCG, when a user creates an OBC, what it's going to do for you is going to create a dedicated bucket for that application, for that developer, and it's also going to create a Nuba or MCG account that is going to give you an access key and a secret key that is going to provide access, or it's going to give you a way to authenticate against the S3 endpoint and start using the storage. Another really nice thing from OBCs is that you can get into your deployment, into your pods, the access key and the secret key in a dynamic way using environment variables. So really, when you create an OBC, in the namespace where you create that OBC, a config map and also a secret is going to get created with the data that you need to access that bucket. So you're going to get the endpoint, you're going to get the access key and the secret key, and it's really easy to introduce that into your deployment config or your deployment and use it to actually access the object storage, access your bucket, and start working with puts, gets, whatever you need to do with your object storage.
All right, so question. So, okay, so as I remember from what you're saying, from the development point of view, when you use OB, like it's very, you do next to nothing. The config maps are done for you, the secrets are done for you, you get in the environment variables that you need to access it. Are the buckets transient? Like do they go away after, they're not persistent, correct? Or is that tunable, or is the idea that it's a bucket that pops up for use and as soon as you're done with it, it disappears?
Yeah, it depends in the policy that you configure, but by default, if once you delete the OBC, also the bucket would get deleted. So it really has the life of the OBC. Once you have finished using that OBC, if you go ahead and delete that OBC, the bucket that is storing your object stores would also get deleted.
Okay.
So that's something that you could also configure for it to be deleted or not once you decide that the OBC doesn't want that you don't need it anymore.
Okay.
And then just the last two slides that I have that we wanted to speak about and give a little bit of context so we can later better understand the demo that we're going to show is speak about the two different bucket types that we have in MCG. Because we have data buckets, as you can see in this slide, and the thing is that when you deploy ODF and MCG gets installed, by default, out of the box, a backing store is going to get configured for you. This is really nice because you can start using MCG without actually having to go into the configuration and start configuring a backing store. It's going to get deployed for you by default. And the actual backing store that gets deployed depends on where you have installed OCP and ODF. Meaning that if, for example, we have deployed ODF and OCP in an AWS deployment, MCG is going to create a default backing store of AWS S3. So we're going to start using, we're going to start storing when we add objects to AWS. If, for example, we do an on-premise deployment, it could be VMware or bare metal, by default, the backing store that is going to get created for us is Rados Gateway. That Rados Gateway is the object service that is offered by Ceph, by ODF. So really, the objects would be stored on premises, locally there.
Okay, but from the front end, the developer doesn't care. It's there, it's working. That's really from the data engineer and your administrators on, right? So if you need something complicated on the back end, MCG allows you to have that, but the front end is still simple. It's just a bucket. Okay, all right, just checking.
Yes. From the user, let's say user application experience is always the same. You have you request for an OBC, and that OBC is going to give you everything in your namespace that you need to access. The only thing that, as we're going to see on the demo, is that you can have different bucket classes, and then the application or the developer can ask for a certain bucket type. So you could inform as a storage administrator to the developer, okay, we have 3 bucket classes that can do different things that we're going to show now. They have different properties, and you can choose, depending on your use case, to use one bucket class or the other. No, in the same way that if we're speaking about persistent volumes and persistent volume claims, you also have storage classes, no, where you can have different storage classes that point to different storage appliances or different storage configurations. No? So we have the same concept that we're going to show in the demo of bucket classes. Going back to data buckets, when using data buckets out of the box, so when a user uploads an object and he's using a data bucket, the data is going to get manipulated by MCG in the sense that it's going to get deduplication, compression, and also encryption. No? We're going to have encryption on transit and also at rest. This is great because out of the box, we get all of these new features, but we have to take into account that because the data is being manipulated and moved around by MCG, that we can only access that data from the ODF OCP deployment where that MCG is deployed, no? Where we have that S3 endpoint. So if going into the AWS example, if we have an OCP deployment where we have an AWS backend store, and we have uploaded some objects to a data bucket, if we try to access that same data through the S3 endpoint, no? So going directly to AWS into the bucket in AWS using their servers, we could see the bucket, you're going to see it, but you're not going to be able to use the data, no? Because it's encrypted, it's chunked, no? So really MCG is manipulating that data and taking care of that. So that's an important thing to take into account with data buckets. And then this is just very briefly that also with data buckets we have data policy, and we could do multi-cloud, no, configuring a mirror between AWS and Google. In this sense, again, for the end user, the application is completely transparent, but in the backend, an object is going to get copied to each of the clouds. No, so we are already working with multi-cloud, and we have one object stored on each cloud provider. We could also go hybrid. Again, we could set up a mirror between our data buckets, and each object that the user uploads would be stored on premises and also on AWS. And we also have multi-site, no? But that's a little bit the data policies that you have with data buckets. But going into namespace buckets, so we don't take too long, the main difference that I just wanted to point out with namespace buckets is that MCG is not touching the data in any way. So when a user uploads an object to a namespace bucket, it's going to be stored on the backend store as plain text. No, so it's going to be exactly in the same way as it was on the source. There's no deduplication, there's no compression, there's nothing like that going on. No, so the object is just going to get stored as it was when it was unloaded by the user.
Okay. So if you needed encryption, and if you wanted to have it encrypted, all of the benefits of the data bucket, you can't do that with namespace buckets, or you would have to take care of that part yourself. Okay, so it's important to be aware of what each type of bucket offers you, so that you don't choose the wrong
absolutely
one.
Absolutely right. No, so the big advantage or the really nice thing about namespace buckets is true that we lose encryption, we lose the duplication, all of those good features, but you have the advantage that in this case you can access the data from the cloud provider. So going back to our AWS example, we could perfectly go with a namespace bucket to AWS, and through the AWS S3 endpoint, we could access the data that we have uploaded to our namespace bucket. So we could read, write, work with it in any way. That's because it's just plain text. There's no manipulation, or there's nothing being done by MCG to those objects. So even if we, for example, completely lost our OpenShift cluster, we could still go with an S3 client to AWS and have all our data there available. No, that's a really nice thing that namespace buckets provide.
Awesome.
And then this is the last slide that I have, and this is going to explain just at a high level the demo that we're going to go through. And here we want to take advantage of all of the things that we have been mentioning. No? So what we have here is we have two OpenShift clusters, one on premise and the other one on AWS. And what we are going to deploy is an application. In this case, it's a very basic photo album application that uses object storage. And we're going to configure or we're going to use as the backend store for our photo album application that we're going to deploy on-premise, we're going to use a data bucket. We're going to use a data bucket because we want to have encryption. We want to have all the goodness that we get from a data bucket, compression, and also deduplication. And also we want to make sure that we are storing all of those objects on-premise. So by default, the application, the photo album, when he uploads an object, is going to go into a data bucket. Because this is an on-premise deployment, as we mentioned before, the default backend store that gets configured is going to be Radius Gateway, so all of the objects are going to be on-premise. But then we can go a little bit further and say, okay, and what's going to happen if I lose with a disaster? I lose my OpenShift deployment, I lose my cluster, or there's a problem in ODF. So I want to give a little bit of more resiliency, we could say, to our data. And then I'm going to say, okay, I'm going to configure bucket replication between our data bucket and a namespace bucket. By bucket replication, what I mean is that anything that the application, our photo album application, gets uploaded to the data bucket is going to be replicated to our namespace bucket. And this namespace bucket is going to have as its backend store AWS. So really, anything that we upload to our data bucket is going to get stored on premises, and it's also going to get stored on AWS, with the advantage that because we are using namespace buckets, what's stored here in AWS is completely in plain text. That means that we could access this data through directly AWS, for S3 client, or we can also access that data from another OpenShift cluster or another Kubernetes cluster, or anyone that has access to a bucket. So then what we are also going to do is we have an OpenShift on AWS, and we are going to configure on that cloud OpenShift that we have deployed another namespace bucket pointing to the same source. So this namespace bucket and the one on AWS and on-premise, they are pointing to the same data in AWS. So we're going to have the images available on the on-premise cluster. I mean, by images, I mean what we upload through the photo album. We're going to have it available on-premise, and we're also going to have it available on AWS on the cloud.
What an easy way to replicate. I mean, it's easy, right? You just, and to change things underneath without your users knowing what's going on, so that you can manipulate, like if you have an outage, or you want to add another bucket or something like that. Okay, so I want to see it. Are we ready? Can we see it?
Yeah, okay, let's go ahead.
Okay.
So let me know if this is more or less a decent size for the fonts.
Yep.
Okay, so what I wanted to show you first is just so we know I have two contexts configured. By context, we mean that with the kubectl command or with the OC command, we are going to have an on-prem, and I also have on AWS. So just so you know, and I will tell you that sometimes we're going to work on-prem, and sometimes we're going to work on the OpenShift cluster on AWS. Okay, we are going to start with the on-prem cluster, and here just to give you. Just so you see that it's an OCP cluster, we're using OpenShift version 4.10.17. Also, how can I show you? Okay, that we are actually working in on-premises. We could do something like this. Yeah, so this is all our master and worker nodes, and really what I wanted to show you is that we're running on vSphere, just to show that this is our on-premise cluster, okay, that we have deployed and we're working on-premise. And just finally, to give a little bit of context, we can also check that ODF is deployed. So as you can see here, we have already deployed ODF, it's up and running, and we have our storage cluster ready.
Okay, and just as a reminder, people, this is a full ODF deployment. This is not MCG standalone. This is because we're using the Radius Gateway. We need Ceph. Ceph is in place. This is on-prem. MCG is there as well. Okay.
Yeah, thank you for that. Yeah, I will do also an OC get pod so we can see that we have all the full array of things. Now we have everything related to Ceph. We have Nuba, that is MCG, so and all of the CSI drivers. So this is a full ODF deployment.
Okay.
Okay, so going a little bit into Nuba, and you brought up a good point there, Michelle, about what gets deployed by default. I just have deployed ODF. I haven't done anything, but I wanted to show you the backend store that gets installed by default, now that we just briefly mentioned before. And also I wanted to bring up that I'm going to use the Nuba CLI. You can work with directly with the CRs and CRDs available in OpenShift, but the Nuba CLI does some work for you, and it's quite nice to work with. So I prefer to use it in my case anyway.
Okay.
So let me just show you backend store list, what gets deployed by default. So as you can see here, without doing anything, we are going to get a default backend store that we mentioned, and because we are deploying on premise, it's actually going to be a Rados Gateway backend store. Here we can see that the type is S3 compatible. We can also do a status that is going to give us a little bit more detailed information. And there we can see that we're going to use the Rados Gateway endpoint. So here you can see that we are using RGW. This is the Rados Gateway endpoint provided by ODF, by Ceph in our deployment. Just to remark that we are deploying on-premise. If we store something into this backend store, it's going on-premise. Okay. And it's going to also use a data bucket. So we're going to get compression, deduplication, and everything related to that. And last thing that I wanted to show before we get into actually configuring things is the bucket class list. And just to give a reminder, the bucket class is actually kind of a storage class. So what we can do when we actually need to use a storage, we are going to use an OBC, an object bucket claim. And what we can do is that we can select which bucket class we want to use with our OBC. So if, for example, I wanted to use this one that gets deployed by default, that is actually pointing to what I just showed before, the default backend store, we could mention this OBC, and we're going to show it in a moment how we actually reference that in an OBC deployment. Okay, so everything that I showed at the moment gets deployed by default when you install ODF. So the first thing that we want to do, and I'm going to go into this slide that maybe is just a little bit more complex, but I just wanted to show the steps that we are going to fulfill so they make more sense to you. So the first thing that we are on our on-premise OCP cluster, the first thing that I'm going to do is deploy the photo album application using an OBC. And the OBC is going to be using the default backend store that I just showed you, that is actually going to Rados Gateway. We're going to use a data bucket with this OBC, and it's going to go to Rados Gateway. So everything that gets deployed, so every image that gets uploaded to MCG with the photo album app is actually going to end up on our Rados Gateway on-premise. Okay, so let's go ahead.
Wait, quick question. So in that diagram, after the photo album, where you have MCG endpoint, that's the internal endpoint, right? Just to clarify, like there's an internal endpoint and an external endpoint. I assume the photo album is going to use the internal endpoint.
Yes, okay. That's a very good point. So when you are working with applications that are inside your OpenShift cluster, so there are applications that are running on your OCP, you are going to use the service, that we will call the service or the internal endpoint. If you need access from outside to the S3 endpoint, you will use the route, that you will go through the ingress route, and then you will use that. So for all applications, we always recommend going directly to the service, because you can also, let's say, reduce some costs. If, for example, you are deploying in AWS and you are using a route, it's actually using an elastic load balancer, and you get also charged by the hits that you get into that elastic load balancer. So that's something that you can save. If you're on a cloud provider, you can save some money using always the applications. Yeah.
Okay, thank you.
Yeah, so then what we want to do first, as I just mentioned, is just deploy the photo album on premises. So I'm going to use a script to deploy it, but really all that is done with the photo album that we will also share the link to the Git repo. The only thing that it does here and that I want to show is that it creates this object. So it's going to create, as you can see here, an object bucket claim that we have spoken about before. And then I just wanted to share with you this part here. Now, what the name of the object bucket claim is going to be on-premise photo album, OBC on-prem photo album. So we are sure, and we also know just that we are using on-premises. And the thing that I wanted to point out is the bucket class. So using inside the specs this additional config, we can select which bucket class to use. At the moment, we just have one, as I showed you before, and we're going to use that default bucket class. But when
if you didn't specify that, would it default to that in this case? Okay. All right.
Yeah, it defaults to this one. So this is really a little bit redundant, but I just wanted to show and make sure that people know that we're actually accessing this one. But it's true that if we removed it, it will work also perfectly. No?
Okay.
Yeah, so we have an OBC, and that's going to deploy an OBC to this new default bucket class. And then the other thing that it actually does is a deployment config. So it's just going to deploy our application. And I just wanted to show here also how it uses secrets to get the access key and a secret key. That this is when we were mentioning before that it's really easy for the developer or somebody that is deploying an application to get access to the access key and the secret key from the application. That's an example that we have there.
Okay, so all you need to know, as see under env, you just need to use endpoint URL, bucket name, and the regular AWS access key stuff. As long as you have them, and you just let it populate. Okay, nice.
Yeah.
That's just done automatically for you. So awesome.
Yeah, once the OBC is created, everything gets populated. So that's really nice because it's really dynamical in the sense that we can have everything, as you can see here, we have it on just one YAML. No, the object bucket gets created, and then the deployment config, everything done dynamically, and it's really easy to automate in that sense.
Okay, and it's keying off the name of the OBC. Perfect. Okay, great.
Yeah. Yeah, the secret has, as you mentioned, the name of the OBC on the project or a namespace where you created the OBC. So I'm just going to run this with a script, but really the script, the only thing that it does is just first make sure that it deletes everything, no? And then the only thing that it does that you can see here is actually apply or create the app.yaml that I just showed you before. And as you can see here, the object bucket clean is going to get created, also our deployment and the service, no? So let's check that everything looks okay. So as you can hear, the OBC has been created. We have called it on-prem, so we don't get confused later on that we're also going to create another OBC, and it's bound. No, when we see it bound, is that it at least has been able to create all of the Nuva bucket, all of the stuff that it needs to create. Let's check if our actual application is up. Yeah, we can see that is running. Next thing that I'm going to do is get the route, because I just want to show you on the browser this really amazing application. So that is this is
amazing
really,
photo application. Okay, so you're gonna upload something.
So this is what we have. Select a photo that we can select. I'm just going to select anything here and upload it. And really, when I'm doing this upload, going back to our diagram, let me make it a little bit bigger. What I'm doing is actually uploading to the MCG endpoint. It's going through the OBC and it's getting stored on our backend store. So the first part of our deployment is ready. Our application is working. Everything will be great. Okay. But now we want to take it a step further, and we want to also give it some redundancy, some high availability, or increased reliability, we could say, to our object storage. So what we're going to do is now add this part that we have here. No, we are going to first add the OBC, a new OBC that is going to use a namespace bucket, and the namespace bucket that is going to use is in AWS. Okay, so now I'm going to show you this part. We're going to create a namespace store, then we are going to create a bucket class, and finally the OBC to use it. So let's go through these steps. And once we have these steps ready, then we can configure bucket replication. It's important to notice that bucket replication is configured at the OBC level. So this is quite nice in the sense that a normal user could configure bucket replication for his things. No, if he wanted to do it without the admin, he could perfectly do that by himself if he has enough permissions. That's if you're doing bucket replication at the OBC level. It's true that there's also we can set replication at the bucket class level, but today we're only going to see OBC and take into account that this could be done by the actual owner of the application, let's say.
Okay.
Okay, so the first thing that we need to do then is we need to create a namespace store. Let me do it clear here so we have it, namespace store, and let me get the command and we can go through it and I will explain you a little bit what we're doing here. So using the Nuba CLI, we are creating a namespace store. Okay, so it's going to be for a namespace bucket, create. This is the type of backend store now for this namespace store that I'm going to use because I'm using AWS. I'm selecting this type, no, AWS S3. If, for example, we will use Rails Gateway, that you could also use it, or any of the other backend store that we can have available, you should change this type. Okay. This is the name that I'm setting. This could be anything, but I'm just setting it as AWS S3 namespace. And now I'm going to enter the access key and the secret key for a bucket that I have already set up in AWS and that I'm going to show you. No? So let me just go here a moment. This is the S3 console in AWS. This is the AWS UI. And as you can see, I have previously set up here a bucket. It's empty, there's nothing here, but I have just set up the bucket. So we also have an access key and a secret key, and we don't have to spend time with this. But really, what I'm doing is I'm configuring the namespace store to use this bucket as its bucket store.
Okay.
So let's go ahead and create it. This is one nice thing of using the Nuba CLI, that, for example, the secret that you need is created for you. The secret that you need where you store the access key and the secret key is stored for you. If you do this with CR and CRDs, with the OpenShift CLI, you have to do it into steps, for example. Okay, so we have our namespace store. Now we need to create the bucket class. So again, this is our command. We are creating a bucket class, create bucket class. It's a namespace bucket class because we are using namespaces. Single, it means that we are only using one namespace store because we didn't mention this, the side of the really nice features that we have in namespace stores, that we can also aggregate several buckets to our backend by offering just a single bucket to the end user. But we won't, because we're not going to cover that in the demo, we can just ignore it for today, and maybe we can go back to that topic another day and show also that really nice feature that we have with namespace buckets.
And could I add later on? Let's say I thought you could add them later. If you start with single and you just want to add another one, you can just add another one. Okay, awesome.
Yeah, that's a really good point. As always, as we say, offering that consistent experience to the user, he won't even notice. Right. But you could add more namespace stores to this same bucket afterwards. And you can also chop and change as you need without the user noticing. Okay. So so we have this bucket class. This is again the name. So I have choose AWS S3 bucket class, and then we are setting the resource. The resource is just the namespace store that we created a moment ago. That if you remember, we gave it this name, and then finally the project that is OpenShift storage. So let's create this bucket class. Perfect. So now if we do,
so if you list the bucket classes now, we should see, okay, two of them, the default and this new one. Okay.
I always forget to specify the project. So just as you mentioned, Michelle, we now have the one that we created by ourselves. That this is the BC that is also using, as you can see here, namespace. So we are using a namespace store. And we also have the default one that we used before. So if you take a look, our photo album application is using this one, and that is on-premise. And now we have this one that we could say that is in the cloud, or in a cloud provider.
Okay.
Now that we have this configured, what we want to actually configure is the OBC, because we need an OBC to do bucket replication. So
So you're gonna create the claim, the object bucket claim, which in turn creates a bucket, but it's all gonna use a bucket class of what we just had, the AWS one. Okay.
Yeah. So as you can see here, exactly the same or very similar as the one that we used before. It's an object bucket claim. The big difference here is that we are, instead of calling it on-prem, so we are clear that this is on AWS. I'm using the AWS name. And then the most important part is that the bucket class that we're going to use is AWS S3 bucket class that we just mentioned before. No, so
perfect. Okay.
We are sure that this is going to use what we have in AWS. So just create it. And now let's do an OBC. And as you can see, we have the on-prem one that we had before and where our photo album application is currently writing, no? Where it's uploading objects. And then we have the bucket on AWS. That's perfect. We have everything set up. Now the thing is that we want to configure replication. No? So let me just go a moment to the diagram again so we don't get lost. So we have everything that you see here now. We have it ready. We have our OBC on-prem. We have our OBC on AWS. And now we want to do this part here that is configuring bucket replication. We are going to configure bucket replication in one direction. So what we are going to do is that we're going to set bucket replication. So when we upload something to the on-prem photo album, it's going to get deployed on AWS and it's going to be accessible here in AWS. No?
Okay.
Perfect. So let's go into that step. It's true that we could have configured bucket replication straight away, but I wanted to do it in 2 steps just so we better understood how it works. The thing is that now we want to edit our on-prem OBC because I want to configure the replication from on-prem to AWS. So just let's edit this, and here in the additional config we need to add an extra line that I'm going to get that I have it prepared here. It's aligned with replication policy, and now I will explain it so we better understand. So what we're doing here is we are setting a replication policy for this OBC. The rule ID can be anything, but I'm just trying to set something that makes us better understand this. No, so really what we're saying here is that we are replicating in the direction from on-prem to AWS. And then we are setting the destination bucket. Now, this is the destination bucket where we want all of our objects to be synced, copied, or whatever we want to call it. That in this case is the AWS OBC photo album that we just created a moment ago. So this is really going to be our namespace bucket where we are going to do the replication. And finally,
yeah, I was just about to ask, so what can we do with prefix? By having it be empty, we're copying everything? Is that...
Yeah, that's correct. But you can do really fancy things in the sense that, for example, you could say, you can have several rules and you could say, okay, all of the HTML files, copy them to bucket A or bucket in AWS, and all of the images, copy them to bucket in, I don't know, in IBM Cloud. No? So you could have several rules with different filters, and the filter you can use asterisks and all that kind of thing. That you could really filter what objects are going to get copied. If you don't put anything like we're using, everything is going to get copied there.
Okay.
Okay, so this is like the first step that we have. So just going back to our diagram, we have set this bucket replication here. So now if everything is working okay, what we should see is that once we upload an image here, it's going to be replicated and it's going to be available in our namespace bucket or even in AWS.
Okay, quick question. So the photo that you've already uploaded, should I see that replicated as well, or is it only new things?
Yeah, everything that is there. So even if it's old, it's going to get replicated because how it works is that there's like a batch job that works on the background, and it comes to life. It examines it examines everything that is on the origin, and whatever is different from the origin to the destination gets copied. The timer at the moment, I have to ask this engineering, but from what I have seen, it can go from depending on when you actually upload an object, it can go from seconds to even 5 minutes. Now I think that 5 minutes is the top of the timer that you have configured. So really, it's a synchronous replication, no? So it's going to be eventually consistent. But I also have to ask if there's an actual way to lower that timer or set it to a specific time. So maybe 5 minutes is too high for your use case. You can lower that, no? So the replication or that batch background job gets started earlier.
Okay.
Yeah. So as you said, everything gets copied, and what we can check now is if it's already in our bucket, we can use. First thing that we need to check is that it actually got uploaded, that we didn't check that before. Okay, it's here. The next thing that we could check on the travel that is going to go for that object, if it's in this photo album, if it's here.
Because it's a namespace bucket, it should just write it out once the replication has happened. It's not encrypted before we see it. Okay.
That's right, and that's a good point to make. Know that, as I just said, this ugly S3 client here, what I really want to meant is that you don't have to actually go through OCP. If you have a client, you can see the data, work with it from an external client, just go into AWS. So at some point when it gets replicated, we're going to be able to see it here. Because it can take, well, it's already here. Let's just check. This is the path that the photo album uses. That's a little bit ugly, but as you can see, we have our image uploaded. Nice. So it has done this traveling from here, no, from on-premises, it has gone to the cloud, and now we have it on our S3 bucket. So just to finish and give it the next step that we could give it is what we're going to do now. No, we're going to go to our AWS cluster. Let me make this a little bit bigger. We're going to go to our AWS cluster. We are going to configure the namespace store and the bucket class, and then we are going to configure the photo album to use the namespace store that is going to access the same data. And this is really nice in the sense that you could, for example, this is a silly use case, no? But if for example, you had a full failure on your on-premise cluster, you could have here a global load balancer or something that would point users to AWS instead of on-prem, no? If you had a full failure, and they would be able to work and have access to the same data, and your application would keep working without any interruptions or issues, no?
Nice.
So let's very quickly cover that. As we mentioned before, I'm going to change context, no? So now I'm moving on to AWS. Here, I want to show you just a moment again that we're actually on AWS. So as you can see here, well, you can't see very well, but as you can see here is AWS, no? So really our machines have been deployed in AWS, and this is the instant name, no, of our EC2 worker node, for example. So just making sure that we are on AWS. So here, what I want to do is, again, create our namespace store. And the really nice thing is that I can run exactly the same command as I just used before.
Right.
Because we want to use the same bucket. No, we are using the same bucket in AWS. Okay. And again, the bucket class can be exactly the same. We could change the name of the bucket class if needed, but it's actually quite practical to have it the same, because then your deployment, your application is going to consume the same. No? So bucket class, single, perfect. Okay, so we have our bucket class ready, and now what I'm going to do is deploy again the application just to show you. Here in this application, the object bucket claim that we're using is pointing to the namespace bucket. So here I'm not using Radius Gateway or anything. I'm just using the namespace bucket that I just created, and it's going to go to AWS. So let's go ahead and just run the deployment of our application using the namespace bucket. As you can see here, we have the object bucket claim created. Let's do as we did before at OBC. This is bound, so it's looking. Let's see if our application is up. Yep, running. Let's get the route because it's going to be different from the other one. And let's also open our great photo album application. And as you can see straight away, because it has been replicated, this is on-premise. and we have this image, and we're also going into the cloud, and we have exactly the same image synced. So this is really nice because we have a hybrid setup with an application that is running on the cloud and also on premises, and the data is going to be synced for us.
Okay, one quick question. So this is a one-way replication, correct? Like if you upload something here, it's plain text. This is a normal object that ends up in the Amazon, the S3 store. It does not, it's a one-way replication, so it doesn't make it all the way back to the Redis gateway.
Yeah, if the thing is that you can do it, and I don't know if we have time. I have ready to show it, but I don't know if we have time, if we're out of time. But you could do it. So let's say that you lose this cluster and you want to have this cloud photo album application working. You also want whatever gets uploaded here, to AWS, to be copied to your on-premise deployment.
Okay.
So when you bring your cloud back, you're going to have everything there. So you can have bi-directional replication. The only thing that we would need to do is configure the other OBC. We just configured this one. We could configure replication for this one.
Right. So you configure a rule on the non-prem, the off-prem. Okay. Yeah. All right. That makes total sense. So we're getting tight on time.
We can I will just set the rule, but we won't wait for the object to replicate, but just so we just show an example, and then we can close off if you think that's okay. So let me just change context to on-premise, because our OBCs are there. We can clear here, and we have OBC. Policy project demo. We need to move to this one. We have our OBCs here, and what we can do, just as you said, before we edit it on-prem, what we can do is edit this one and then add another line here with that I had it ready here with the replication on the other direction. And then we're going to have bi-directional replication configured here.
And again, we can use a filter there. So if we only wanted to copy back certain things, like that's actually really flexible.
Yeah. And as you can see here, the difference is just on the rule that I'm setting AWS to on-prem on the other direction, and the destination bucket is on-prem doing that replication on that way. So if I now uploaded something here that we could maybe use this one, just upload. And we will leave it here, and if we have time while we close to get it replicated in that time, we can just check afterwards if it gets here. But I just wanted to mention two quick things before we end, and is that this feature of bucket replication has by design some limits that maybe they will change in the future. And one is that you can't use S3 object versioning. That's not actually implemented. And the other thing is that it doesn't track the deletion of objects in the source. And what I mean by that is that if you, on your source bucket, where you have configured a replication, you delete an object, that object is not going to get deleted in the destination. The destination is always like your source of truth, where you have all of your things there. You can that maybe is going to change in the future. I'm sure that it's going to change. It's something that is engineering is thinking about, but just at the moment, so people also know that that's a thing that we have currently with bucket replication.
Fantastic. Wow. Okay, so we're at time. I will be posting in the description all the repos that everyone needs, and maybe some tutorials and more information on MCG. And I wanted to thank Daniel once again for such a fabulous show. And we'll have more planned in the future. Thanks, everybody.
Great. That was fun. Thanks a lot, Michelle.
Thanks.